Using AI is unsustainable, but without it we cannot save the world. Welcome to Follow the Sustainability Trends in Business. Today we'll have a closer look at how sustainability and digitalization interact. When talking about sustainability and digitalization, one thing that surfaces is the huge energy use of AI. In addition to this environmental challenge, there are a lot of social and ethical challenges associated with using these new digital tools. But let's start by the easy one. As we discussed, neural networks have a large number of so-called coefficients, which means that there are a large number of calculations. It might be that if you ask something simple from ChatGPT, for example, then the number of calculations carried out there is 1 million calculations. So 1 and 12 zeros for just that one use. Well, to be honest, it's very difficult to get reliable numbers of the energy use of AI tools, but a rule of thumb, it's 1 watt-hour per prompt for an LLM, large language model, or image generator. And just to remind you, 1 watt-hour is not very much. It's sort of like half a minute of watching Netflix on your television, or it's like a couple of seconds of heating your oven. And this number is possibly going downwards because the models are getting more efficient and the processors or the GPUs, NPUs, the processing units, the silicon is getting more efficient all the time. But it's also possible that these gains may be offset by using larger networks, larger models. So 1 watt-hour would be about, 50 milligrams to 500 milligrams, so less than a gram of carbon dioxide. So using 1,000 prompts, which makes your fingers ache if you type all of them, it's from maybe 50 grams to 500 grams of CO2. That's quite negligible because daily average of our consumption is about 30 kilograms, which means that it's equivalent to maybe 100,000 or hundreds of thousands of prompts depending on the electricity production structure. Or an hour of watching Netflix on big screen is 100 watt-hours, which again is many uses or inferences for these tools. Well, there is a caveat. Some tools use a lot of energy. Movie generation or video generation, maybe much more. Chain of thought models, they trade the model complexity to inference time, which means that they spend a lot more time for the inference. They use a lot more energy, but we don't know how much. It's probably worth of dozens of ordinary prompts. But what consumes a lot of energy is training. ChatGPT-4, it's estimated to have used 50 gigawatt hours or 50,000 megawatt hours of electricity, which is maybe 10,000 tons of CO2. It's worth 1,000 people for a year. That's not negligible. So the training uses a lot of energy. Well, even that's bearable if there are only very few large models. If there is OpenAI's and Google's and Meta's model, it's no problem because there are only a couple of those companies. But if all corporations, companies want to have their own model, which then emits 10,000 tons, then that expenditure of money goes into energy and emissions, and that will be a problem. And also the technology development may be important, so the chain of thought, again, which I mentioned, is something that might tip the balance towards the use of these models. Well, of course, there is an important way to mitigate all these emissions. They are electricity that these models are using. So if you train these models when and where there is zero carbon energy excess, then everything is good. So if it's windy, if it's sun is shining, train the models there because you can do it wherever you have cheap energy. But there are capital expense and operational expense implications, because if you have these expensive computation units that are doing the training and you don't use them when the wind is not blowing or the sun is not shining, then of course your capital expense goes up. So it's a complex issue, but it's totally solvable. Data centers are a huge emission source and energy consumer in the world. AI contribution is not known. There are widely different estimates, but it's quite likely much less than Bitcoin. Which one is more useful I would like to ask. Bitcoin is about 1% of all electricity in the world. My personal opinion on this is that the energy use of these neural networks or these new digital tools does not kill the show. It just needs some attention. And one of ways of giving that attention is carbon pricing. If you use high carbon electricity for that, then you'll pay more. Here is an example of what is happening. So Microsoft is considering buying the notorious 3 Mile Island nuclear power plant and restarting it because they need to have steady, low-carb electricity. Of course, a huge problem in evaluating this energy consumption is that the model creators, OpenAI and so on, they never tell anything about the energy consumption figures. They are trade secrets. And I think that's a huge problem from the transparency point of view. Well, the other side of the energy coin is what is enabled. One thing is that the future energy infrastructure is extremely complex. It will have centralized and distributed production, different production methods. It will have demand flexibility. It will have storage ranging from pumped hydroelectric power to hydrogen storages to car batteries and so on and so forth. All this is dependent on a number of factors, including weather, but also things like if a weekend is coming so that people want to charge their cars. Optimizing this with traditional algorithms is a complete no-no. You can't do it. It's far too complex. This article by the IEA talks about the necessity of having AI to optimize wind turbines or EV charging. This is a single application field for AI, not a big one, but even small efficiency improvements in the energy production are huge in terms of tons of CO2 or in terms of euros. Another important sustainability-related field is the sustainability data in a business. It's becoming far too complicated. It's multidimensional. You need to take into account your data, your subcontractors' data, their subcontractors' data. You need to take energy use, carbon emissions, water use, biodiversity implications, social implications in the value chain and so on. It's just too complicated for any today's ERP style of system. You just cannot do it. And the calculations are too complicated. And the same may apply to a lot of environmental challenges. For example, what I think of biodiversity is that it's such a complex problem that it cannot be approached with traditional statistical methods or traditional simple calculations. So these modern tools may have a very important point in steering our efforts towards a more sustainable world. And of course, as with any impact, the emission reduction or increase of AI needs to be taken as a difference between two scenarios. If one ordinary prompt consumes approximately the same amount of energy as a human being in a minute, it means that if we can replace 1 minute of human work by one prompt, then all is good. Of course, that might even be renewable energy we're using for that AI. But it's important to understand the Jevons paradox. Here is Mr. Jevon. But the point what he said is that when some resource becomes cheaper, it is used more, and that offsets all the advantages we gained. So everything will disappear as the total consumption will still increase. An example of this could be air traffic or air travel. Air travel was very expensive and the airplanes were not that efficient. Modern airplanes are much more fuel efficient, but still the total fuel consumption is way higher because they can fly much cheaper. And an example in AI could be marketing. So now that we are using text for marketing, we will move to images that are tailored for you. Then we will move to videos that are tailored for you. And once that happens, the energy consumption of generating text, single text for everyone, to personalized videos, it's a huge difference in energy consumption. But is it a difference in the end result? In either case, you will either buy or not. So the result is the same, but we are just using more energy. There is another related pitfall in using these tools, is that you're using very sophisticated models for very simple tasks. If you need to know what 2 + 2 is, please take your calculator because it uses much less energy. It uses nanowatt hours for that task instead of watt hours. Energy is easy to understand because you can put it into watt hours and whatnot, but possibly a much more important ESG area, or area for ESG impacts, is the social area, the S. There are a lot of philosophical, ethical and practical questions related to sustainability, social sustainability of these new tools. One maybe a bit surprising problem is called guardrails and nannies. What it means is that model providers exclude certain fields. The models don't want to discuss some things. And this is quite easy to understand. I mean, it's pretty good, I think, that they don't give you simple instructions how to create biological weapons in your kitchen, or how to make a crime that cannot be detected, how to burgle into your neighbor's garage, or whatever criminal activity. But this is a slippery slope, because then they have a lot of things which are value-based they don't want to discuss. And they have sort of, not their own values I wouldn't say, but they still have a set of values floating around them. And what are those values and who decides them? That's an interesting question, because now we have commercial companies like OpenAI creating their models, not telling us what these guardrails or nannies are there. What is it that the models are not going to discuss? And that's not okay, for example, from the research point of view. If you would like to do, say, social research on how societies work, different countries, there is bound to be opinions that are not politically correct. But if these models refuse to discuss those, then you are in trouble. You can't make that research, or even worse, they sort of ignore them, which means that you get false answers. A very striking example of this is the infamous Black Nazis by Google. A Google AI system, when it was asked to depict Nazis, gave an image of black Nazis. And as far as I know, there were 0 black German Nazis in history, for very good reasons. Or bad reasons, I'd say, but certain reasons. And why did the model provide that? Because it was told that people of color are underrepresented, so it should overrepresent them in its output. So introduce bias. And this is a bit of a problem, because we have 3 views into the world, and when we're training a model, first is the world as it is. We have different people in different positions, and the model could portray the world as it is. The second is we don't have the data for the first one, so we portray the world as it is seen in the internet, and that's quite different from the world as it is, because, for example, the global south is completely underrepresented in the internet. And the third one is the world as we would like it to be. And now we have the first one, which we can't achieve, the second one, which we can achieve, but which is highly biased, and then we try to fix it with some bias to get the third one. Does it make things any better? At least we get black Nazis. And this is a problem because the model providers don't tell us about what they've done. A question related to models, a philosophical question, is related to empathy. Models can be quite empathic, especially the text models. Why not the image models? I don't know. There is some research indicating that patients see these language models more empathic than real doctors, which means that this doctor-patient relationship can be handled by a model. Okay, that's interesting. We also know that models have been used to reduce extremist behavior, so that people who have sort of extreme opinions have been discussing with a language model, and they've decided that, okay, maybe I should a little bit change my mind. Sounds very good, doesn't it? And sounds very manipulative, I think. So it's manipulation. Manipulation for the good, yes. Is that okay? Can we manipulate people without them knowing we are doing it? Now we can, of course, curb all this by regulation. And regulation can make things better or worse. One thing to remember is that whatever we regulate doesn't apply to the illegal players. It doesn't, for example, if the EU regulates something, it doesn't apply to companies outside of the EU. It doesn't apply to criminals, it doesn't apply to police, it doesn't apply to military, it doesn't apply to Russia, it doesn't apply to China. So intelligence services can use. So illegal actors have no limits. And then we have something called jailbreaking, which is an interesting phenomenon. As people have noticed that these models have their guardrails and nannies, now they are trying to coax these models to surpass these guardrails. If you're interested in this, just Google or use another search engine, not to advertise Alphabet, and search for jailbreak, AI jailbreak. There are legal challenges with AI, legal philosophical challenges. If an AI makes a mistake and something happens, a law is violated, who is going to be punished? We have an autonomous vehicle, so a car that is driven by an AI system, and it speeds and it gets into the speed trap, and the police is going to write the ticket to whom? The neural network, the creator of the neural network, or the person who happened to be in the car during that time. Nothing happened. Someone just violated some rules. We as human beings, we want someone to get fined. Someone will need to get that ticket. But who's that going to be? Are our laws AI proof? Again, let's go back to traffic code. Almost all traffic codes in the world start by saying that the driver needs to be, or everyone in the traffic needs to be careful. What is careful? Please quantify it. So our laws are not AI proof. We know that our laws have a lot of holes, and then we have courtrooms full of cases where we try to find the correct interpretation for the law. Is that AI proof? If that is, whom are we going to punish again if something happens? And further down the road, full society. How does a society look when we have only manual workers and highly skilled professionals because these digital tools do everyone else's work? Or if we have physical robotics, we have only highly skilled professionals. 20% of people are working, 80% are not because they don't need to. Sounds fine as long as you start to think of purpose of life. What is the purpose of life of those 80%? And how do you fix the thing that 20% is creating all the value? Do you tax them to death and give that money to that 80%? Well, that sounds fair, but then what is the motivation of the 20% to do anything? Shouldn't they just skip to the 80%? How does this motivation structure work in a society like that? Who pays the taxes? AI does the work. Is that a utopia? Dystopia? Middle class will disappear. I say this because middle class has already started to disappear due to technology, and that will go on, so we'll get rid of middle class. And that's, of course, also one root cause of polarization. Difficult questions, I'd say. Well, if you like legal think of copyrights. Is an artist's style copyrighted? Not the paintings or whatever, but their style. Can a neural network read newspaper articles? Why do we have different rules for a human and an AI? Because they learn the same way. Both memorize things the same way as far as we can know. Copyright will be an iffy thing because we will have sort of like personal music neural networks. It knows what kind of music you like, and then it plays completely new music of that style, creating all the new. But then what will happen to culture, or people whose profession is culture? And what will happen to the training data? Because now that music is a good example, we have neural networks creating new music, new hits, which become part of the corpus that new neural networks are using as their training material and trying to create, do they have free will? Anyway, trying to create new music based on that. So sort of the learning material or training material is poisoned by AI. This is already what we see with text. What will happen? Will we have AI developing music based on the AI developed music? Is that any different from human composers? Anyone's guess. And then of course we have the grim side of AI warfare. We have physical warfare, we have cyber warfare. AI is very capable in both sides. Do we have any rules? Should we have any rules? Is it sort of like atomic, chemical, biological weapons, AI weapons at some level? I don't know. And of course, if we talk about war, make love, not war, so we have to talk about love and maybe love making. What if digital and possibly physical lovers cater our needs better than flesh and bone ones? So you have all that, empathy and intimacy and closeness and physical side and stuff without needing to face the problems of a relationship. How will this reflect into social structures? No more mating and dating. By the way, when I suggested this topic, talking about love and making love, ChatGPT suggested I wouldn't, so I just bumped into a guardrail. Sensitive topic. Now, as humankind, we are in a completely new situation. We are with aliens, I'd say. We need to think of what is human, what is us, what is human, and what we want. There are gazillion paths the technological development can take. There are different paths we can take. We cannot know where and when technology develops, but we have to keep a close eye on it. I'm sorry, I have more open questions than answers. And now, if we go to the business implications, if you look at what kind of changes we may have in society, the implications, even the outside implications, are huge. So it will be potentially very disruptive in the real sense. Well, a lot of speculation. Next episode, I hope, will be more solid stuff and less hand-waving. See you!